Kia ora. So what we're doing here is I'm just going to quickly run you through how to make your graphs and interpret them. I've shown you this once before, but I'll just do it again. So first of all, you need to start out Insight, and you need to go to the VTI function. Was it VIT? Sorry, VIT, Visual Inference Tool, and go to randomization tests. That's the one you need to click on. So when you do that, you need to import your data. That's clicking the little import data thing, finding wherever it is you've saved your data from your experiment. This should be saved as a CSV file, so CSV comma delimited. And if you have that, then it will upload it, no problems at all. So what you can do then is you just grab your variables and drag and drop them into the place. You can see here 16 of each. Now this data is the data that I showed you in class. You may remember it's the one about the nectar cube, or the cube that if you look at it for long enough it looks like it's orientated in different directions. So as I say, we did this briefly in class, and I just want to use that data as a good example. So here we go. So this is drawn, I've dumped that data in. I now go to the little tab at the top here that says Analyze, click on that. We're going to use median is our difference, and then I'm just going to say record my choice. There we go, done with that. So here you go, this is the research data, and it's showing that these are the results from a control group against the group that we're concentrating. Just to give you some context to this, when you concentrate, you're trying to concentrate on keeping the cube in the same position as what you saw before. So the people control were just watching the cube and seeing how, and counting the number of times they saw it change its orientation as a visual phenomenon. And the concentrating, they were trying their hardest to keep the cube in the same place as they saw it, and then still while counting how many times it changed its orientation. Anyway, that context is not so much as important as you understanding what to do and what it is we're doing in a randomization test. So I'm going to go through and do one randomization. So I'll move this over to the side, and what you can see is all the data here. You can see that all of these little guys, these are all your control group. These are all of the number of times they counted at swapping over a given period of time for people who are concentrating. So that's your actual data. What we do when we randomize is it takes the data down, muddles it all up, and randomly allocates it into the two different groups. It doesn't matter now whether it's actually control. That was control, now it's a concentrate. That was control, stay concentrate. This was a concentrate, now it's a control. I've just randomized it. It's just looking to see if you can, what the difference in the mean is if you just randomly scramble people up. So give them into, randomly put them into the two different groups. So we can do that again. Let's let go, do it again. Not there, randomly allocated them into two different groups. Then, what difference in the mean? It's actually saying we keep in this difference in the median being allocated. I can now, maybe if I bring this a bit closer, I'll just bring it over so I can see. Do that 5 times, and it's just going to pull apart the data, randomly allocate. Okay, so we've got a difference in the mean, do the median, do it again, difference in the median. So this is how big a difference it is between the median of the control group when you randomly put people into those groups. So they kept this, the scores are the same, they're just changing which group the person who scored that with. The whole idea of this is that we want to know if the difference in the medians we can observe from our observation here, if that difference in the median, 2.5 in this case, can be made just by randomly putting people into groups. Because obviously these people have been put into concentration group and the control group. And we want to know, is the effect here, is that just because of the people who are in that group? Or because they were put into those two groups randomly? So if we could generate that result, that 2.5, regularly just by randomly putting people into the group, then we would have some reason to think that there's no effect happening from our experiment. Our experiment hasn't produced a visible effect. Random chance alone can make that just by randomly putting people into groups. And that's the key, because if we can't get it to produce that difference in medians through random allocation, or at least we can't get it to do it very often, that starts to indicate that we're seeing something. Something's happened in our experiment that is causing that difference, and it looks like it's our intervention that's causing that difference. So I'll talk about that marker as we get down. So I've done that a few times. You can see that process. I'm going to basically speed that process up, and what I'm going to do is I'm going to record the results down the bottom here. You're going to see this little part down the bottom here. I'm going to record the results. These results are a difference in the medians. So it puts a dot down for the difference in medians. So in this case, it's just got once to show you. So if I go through and I get it to do that once, it's randomly putting people into groups. It calculates the difference in the median. Oh, it's given us a difference of negative, what's that? Something like -2, something along those lines. So -2 there. So that's the difference in the median. So every one of those lines, that difference becomes a dot and puts it. 0 means the medians are exactly the same. And then obviously this little line out here will produce a dot somewhere here at 2.5. So I'm going to now do this 1,000 times, because I'm going to build myself up a little bell curve and just see how often, if I randomly allocate people to groups 1,000 times over, how often do I get a difference in the median as large as the one we observed in our experiment? As I say, if it happens a lot, then it means that can happen just through random chance. Maybe it was just the people we put in and their random allocation, nothing to do with the experiment. But if it doesn't happen very often, then maybe, or probably, it's to do with your intervention. So we're just going to now, or your treatment. So now I'm going to take the tail, which basically just moves this arrow, the difference in the medians down, and just see how often did we get these difference in medians bigger than the one we observed. And what this is saying is it's only 17 out of 1,000 times did we get a difference in the median bigger. Only 17 out of 1,000 times. That, with a little bit of maths, you can works out to be at 1.7% of the time. That's not very often. What that is saying is that random chance alone can't be the reason why we have this difference in the median. It's very likely because of the intervention, not through random chance alone. Where do we draw the line? How do we know what's through random chance alone? Essentially anything that is below 10%, or if there is a 1 here, so as soon as that number there goes above a 1, we go over 10%, and that means that a lot of the time, or 90% of the time, we can't get a difference in median larger than the one we saw here. Now this is actually saying that 98.3% of the time we can't get a difference in medians as large as that. Which means that pretty much always we can't produce this through random allocation of people. It means there must have been an effect. Once that number gets up to 10%, maybe 11%, we start to be less sure, and we would say that it's this, because it could be produced through random chance alone, 100 out of 1,000 times, then we are not confident that we're seeing an effect due to our experiment. It's just possibly just through random chance alone. Okay, I hope that made some sense. Talk to me about it in class if you're ever unsure.